All right. The idea behind needing law of sines and law of cosines is we learned this about right triangles back, I would like to think, in 8th grade. If not, in geometry, hopefully. But this only worked when we had a hypotenuse, which meant it was what kind of triangle? A right triangle, right? But it doesn't, these laws don't work. These sine equals opposite over hypotenuse, those ratios don't work unless you have a right triangle. Well, some mathematicians extended this concept and showed a way to make these two laws work for all triangles, okay? 10.1 in your book is law of cosines and 10.2 is law of sines. We're going to cover both today because it's review for all of you. Area of triangles is also covered in 10.2. All right, a few of the prerequisite skills you need to know. Just what mode do they want us to be in here? Okay, put your calculator in degree mode. And then how do you find possible values of an angle whose sine is 0.345? You could. Sounds like a lot of work to me. Okay, second sine 0.345 in degrees gives us what? 20.2 roughly degrees. Okay, we have a problem when we push second sine on our calculator. We need to think about the graph for a minute. The sine graph does this. In radians, this was 2 pi, but what would that be in degrees? 360. So this spot right here is 180. When we have, where is the sine hitting 0.345, there are 2 possible places before 180 degrees. Okay? One is going to be acute and one is going to be obtuse. We need to examine the possibility of both of those angles working. For this problem, there would be 2 solutions because we don't know any better, okay? But when you have a triangle and you have set up a problem and you found a 20.2 degree angle and you test to find the other one, sometimes you'll get to throw one of the solutions away, and I'll show you what that looks like in a second. But how do you find the other one, guys? If this is 180 right here, how can we find this other? Yes, so we're going to go 180 minus 20.2 is, okay. Now, just humor me. Type the sine of 159.8, not second sine, just sine. Sine of 159.8. Did you get about 0.345? Okay, so both of those have the same sine value. Now let me talk about, this might have been a law of sine question where you had the sine of this angle is over here across from this, and the sine of some other angle is across from something else, and you set up the law of sines, and at the end of the question you typed this. So you have 20.2 as your possible theta value here. If this was the problem, which probably makes no sense for the rest of it, I'm just making something up, but if this had started out to be the problem, would 20.2 and 159.8 both work right there?
No.
No. 2 reasons. Somebody tell me one of them?
Because one of it's acute.
Okay. Yes, if you're just going by the way it's drawn, can't assume anything from the way it's drawn. But do you remember the longest side has to be opposite the biggest angle, smallest side opposite the smallest angle? So if this were 10 and this were 70, this 3 would indicate that this has to be an angle less than 70. Okay? But the more important thing, can you have a 70 and a 159.8 in the same triangle? No, a triangle can't add up to more than 180, right? And that's the reason you'll get to throw out one of the options very frequently, is because it would make the triangle add up to more than 180. But for our problem, we need to put both of those solutions, And I'm going to write a note up here to myself that whenever we do law of sines, if we are finding an angle, we're going to do second sine, and then we need to see if 180 minus that value is also possible. Okay, so the supplement of that value. This should not, I'm sorry, this should not be a theta. This is some decimal blah blah blah, and it will give you theta. Yep, thank you. All right, cosine, let's talk about cosine on the other hand. The cosine graph looks like this. So from here to 2 pi or 360, okay, here's the middle at 180 degrees. How many times can it hit a positive 0.7 between 0 and 180? Once. But you can have negative cosine values. Does everybody see that before you get to 180? Okay, obtuse angles will have negative cosine values. All right, so we're only dealing with this question at the moment. So if you just type second cosine 0.707, you get roughly what? 45 degrees? What about this one? Second sine on number 3. Gives you roughly 60.
Yeah.
Or we did second sine, right? Anytime you type second sine, you need to be looking for the other supplement of that angle, 120. If you type it, sine of 60, enter, sine of 120, enter, it's the same value, right? Okay, so we can't tell whether the angle we were looking for was 120 or 60. Whenever we do second sine, we need to remember that. All right, and this one, only one answer when you do second cosine or inverse cosine. Everybody okay? All right. Now, we're going to talk a little bit about what this would look like on a triangle, but this is law of cosines, this word cosine back here. And this one is all set up. So for now, can you just type this in for me? I just want you to practice typing all that in at once. Be careful. You can hit enter along the way if you want, but be careful, all of this behind the minus sign is all one big multiplication back there. So it'll be easier if you just type the whole thing in. Anybody getting something? Should be a big number. 500 something?
502.1.
Okay. What do we need to do to finish and find x? Square root it, yes. Okay. And that would be units of length that we just found. Now, let's talk about how they came to have this set up for law of cosines. The law of cosines says x is some side length, and 21 and 15 are two other side lengths on this triangle. So you have one side squared plus another side squared minus this 2 is part of the formula always. And then it's 21 times 15 or 15 times 21, doesn't matter, times the cosine of the angle. That angle, in order to use the law of cosines, has to be the angle in between those two sides. So this is kind of a side angle side situation. Remember that from geometry? Two sides and an included angle. Okay? And what the law of cosines helps us find is the opposite side. Right? Law of cosines helps us find the opposite side. Now, On number 6, I just want to solve a simple algebra equation for a minute. If this said 15 equals 8 plus 11 minus 2x, how would you solve that? Okay, you could add those two together if you want and then subtract it over to the other side, right? So that would be 19, so 15 minus 19. And then what would you do? Divide by negative 2. Okay? Nobody in here is going to tell me that it's okay to do all of this and then move it over to the other side, right? Because all of this is multiplied together, yes? All right, I usually write this out. I don't like to write out any more work than I have to. So I usually think, well, I'm going to subtract the 8 squared and the 11 squared both over to the other side. And I figure out what that is. It is 40. And then I multiply all this together, so I have a negative 2 times 8 times 11, 176 maybe? Did I do that right? 2 times 8 times 11? Okay. And then the second to the last step will be to do what? Okay, divide. And what kind of an ugly little decimal do I get?
Well,
40 divided by negative 176. I just want negative 0.227 or something, right? All right, if you want to leave that whole decimal on your calculator, or you could even do what? Yep, you could leave it a fraction, but what do we need to do next to find the angle? Yep, second cosine of, and you could have left it 40 over negative 176 if you wanted it exact.
103.1.
How did I know ahead of time it was going to be an obtuse angle? Remember my little graph a minute ago? Cosine goes from positive to negative on the graph from 0 to 180, right? Where does it become negative? After 90. Okay, so I knew that it was going to be an obtuse angle because the cosine was negative right here. All right, the situation for this question would have looked like this, okay? You were given 3 side lengths, 15, 8, and 11. The angle you've chosen to find is the one opposite of the 15. And if you generally find the largest angle first, law of cosines always works. If you're willing to do law of cosines, you can do it and get the right answer every time as long as you calculate it correctly, okay? Law of sines, there's situations where you have to be careful because it can have 2 solutions, right? So law of cosines always works, but if you use law of cosines to find the largest angle first, then using law of sines to find the other 2 will eliminate that possibility of 2 solutions. So we set up opposite of the angle squared equals adjacent squared plus the other adjacent squared minus 2 times 11 times 8 times the cosine of the angle. All right, that's where this came from. So what situation would this be called? If this one was side angle side, this was 3 sides. Okay? So law of cosines is used for 2 sides and an included angle to find the third side, or it's used when you have all 3 sides to find any of the angles, actually. All right. One more law of cosines. If we subtract this over to the other side, we get 20 something, don't we, on that side? 38? Okay. Over here we get negative 10. So when I divide and go to do second cosine, what's happening? Okay. Gives you an error, why? Well, you can have a negative. Well, that's not gonna be on your calculator, so you need to know how to do these, okay? The programs will not be available when you go to take the test. Yes? Exactly. Does that make sense to everybody? Cosine only goes from -1 to 1, right? Good job, Brennan. All right, so this is not a possible triangle. Now, can I talk briefly about why that is? Because this will help you on the ACT next week or 2 weeks. There's a rule from geometry that says the sum of any two sides has to be bigger than the third side. Does that sound familiar? So 1 plus 5 has to be bigger than 8. Does that work? No. So just humor me for a minute. Would this make a triangle? Sides of 2, 2, and 3. Any two that you add together, 2 plus 2, 2 plus 3, is going to be bigger than that third side, right? Okay. 3, 4, and 9. No, not working. Zach, you good? You know what I'm talking about? Okay. 3, 7, and 10. Yeah, it has to be greater than, if you think about this, guys, if I had a 10-inch ruler here and I put a 3-inch stick here and a 7-inch stick here, right now they're exactly making a line that's exactly 10, right? If I try to lift those up to make a triangle, it's going to come apart and not work. Does that kind of make sense if you visualize it? All right, they have to be greater than, they can't just be equal. All right, one more. 7, 10, and 15. We good? Any two that I add together will always be bigger than the third. Okay, that is important. Sometimes on the ACT, there's a question that has something to do with that, that you can eliminate some of the choices right away if you know that rule. All right, over to this question. This is now law of sines, okay? The situation that would apply for this particular question, the law of sines says if you have a 100-degree angle, across from that is a side that's 82, in the same way that a 45-degree angle is across from a side of x. That's the situation that would have you set this up. Now, we're just cross-multiplying and dividing. So we're going to type 82 times a sine of 45. Your calculator brings up a parenthesis, so you do need to close the parenthesis. And then we're going to divide by the sine of 100. What is it? Okay, and that is a unit of length, right? Not of degrees. Does it make sense? What's the rule we talked about earlier? The largest angle has to be across from the longest side. So I knew right away that this number that's across from the 45-degree angle needed to be less than 82. Okay, does that make sense? Just as a check. All right, let's try. Oh, what was this situation called, by the way? Two angles and a side across from one of them. Which one is it, guys? Law of sines works for either one of those, but if I know two angles and a side not in between, okay, then I can find this by setting up the proportion. Angle, side, angle. If I know two angles and a side in between, I know that one. I do have to find this angle first so that I can set up a proportion, okay? But we know that, don't we? If we know two angles, do we automatically know the third? Okay. No one has forgotten, right, that triangles add up to 180 degrees? All right. Cross multiply and divide on this. 10 times the sine of 30 divided by 4. We get what? What is it? 1.25. Is that going to work? When you do second sine, it's going to give you the same error. And Brennan's going to tell me why one more time. Or this one is sine. Only goes from -1 to 1, right? All right, so this is not possible. Let me show you again what was going on here is that we had an angle A across from some side that was 10, we had a 30-degree angle that was across from some side that's 4. Now, this is hard for students to figure out why this can't work. Let me try to show you by drawing something somewhat proportional. If I said that's 10, and I put a 30-degree angle here, and then see how out at the end of the 10 is supposed to be the 4? If I put a side over here that's 4, what happens is it's not long enough to reach anywhere, okay, to reach that side. That's one way of thinking about it, okay? Why this doesn't make a triangle? Do you remember earlier when we talked about the law of sines can have 2 solutions? Okay, let me give you an example where it would have 2 solutions. If I were to extend this and say this side is 6, it could look like this, or it might look like this. Do those look like roughly the same length, guys? That 6 could go this way or this way, and that would make 2 totally different triangles. All right, with that in mind, let's see what happens on number 10. Can you guys type in number 10? Cross, multiply, divide, and what's going on? Yeah. We need to talk about what that was from geometry too, but let's keep going for 1 second here. 68 times the sine of 48 divided by 63, 0.8 something? Thank you. And when we do second sine, what do we get? 53.3? I'm listening. Or, thank you, Caleb. Anytime you do second sine or inverse sine on law of cosines, you need to look for the possibility of 2 solutions. Let's talk about why that is one more time. If we set this picture up, we have a 48-degree angle across from a side that's 63 centimeters. We have some angle B across from a side that's 68 centimeters. Not degrees. What is this situation or this situation called in geometry? There's an angle, a side, and a side. Okay? In my classroom, we call that the donkey theorem. Do you remember? There is an SSS, there is an ASA, there is an AAS. Do you remember all those? But is there one that's spelled ASS? Spells bad word, right? There is no such theorem. So, the reason there's not in geometry as far as congruence theorems is because it doesn't determine one unique triangle. When you have an angle attached to a side, which is attached to another side, where the angle's not in between, it does not determine. It could make no triangle, it could make 2 triangles, or it could make 1 triangle, okay? It depends on the size of the angle given, the lengths of the sides, but we have to be very careful. Now, this triangle, according to this right here, has an angle over here that could be 53 degrees, 53.3. Would that be reasonable for this picture? 53.3 is across from 68, 48 is across from 63. Does that seem okay? Can we throw this solution away? Can we throw that solution of 126.7 out? Okay. If this is 63 centimeters, I don't want to draw it that way, do I? Sure I can. This one's 68, and there's a 48-degree angle up here, okay? The situation is that we don't know whether this 63 looks like this. Let me do this. Let me see if it'll let me. I don't think I can just... The 63 might be going like this, or it might be going like this. If that 63 is out here, then that 48 and the 53 makes sense. But if we redid the triangle like this, could this one up here be 126.7 across from the 68? Do you see what I'm trying to show you? Okay, it's possible. If it had turned out to be 156.7 and we already have a 48, that'd be too big because it'd add up to more than 180. So we just have to be careful. All right, I did not draw that well and I apologize. All right, law of cosines says any of these are fine. I will give you an updated formula sheet because I really think you need to know law of sines and law of cosines without it being on the unit circle sheet. But the area formulas, I'm not quite as sure. You have to memorize all the area formulas that are on the back. So I will give you some kind of an updated formula sheet. But this is law of cosines. I don't have this memorized. I do. It's really not hard. But this is what I memorized. Opposite side squared equals adjacent squared plus adjacent squared minus 2 times adjacent times cosine of the angle. After you do 5 or 6 of these, you're just going to know it, right? All right. The law of sines looks like one or the other of these. Now, do you do a 3-part proportion here? No. You pick 2, right? Whichever 2 you need. I usually set them up this way. You can set them up upside down. It doesn't matter because we cross multiply and divide to get the same answer. All right? Let's look at number 11. What situation is this? We have 2 angles and a side. Okay, we have angle. We have an angle here. And we have a side over here. Is that? It's good. We're going to use law of sines. Absolutely. This would be an angle side situation. Okay. But before we can set up something's across from something, we know that part. We know the sine of 82 is across from a side that's 100. But do we know the one across from the x, guys? Pythagorean theorem? Subtract from 180. I knew you knew what you meant. I knew you were there. So we need to go 180 minus 15 and 82. What's left over for this angle? 83? Did I hear you right? Okay. So this is the sine of 83 degrees over x. I'm looking at this thinking our answer is going to be really close to 100. Okay? Because if we have the sine of 82 is across from 100, the sine of 83 should be just a little bit bigger than 100, I'm thinking. Cross multiply and divide and we get what? 100 times the sine of 83 divided by the sine of 82. Is it like 100.2 or something really small? Okay, and it was centimeters. It is a length of side. All right, number 2, what can we use to solve this triangle or to solve for theta? Aren't these across from each other? Okay. But we have one angle and 2 sides. This is the donkey theorem. We're looking for an angle using law of sines. So we need to be thinking in our head there's a possibility of 0, 1, or 2 solutions. We're going to have to examine that as we go here. All right, so I'm going to set up the sine of what? Okay, is across from 100 inches in the same way that the sine of theta is across from 30 inches. Cross multiply and divide, and you're going to get a little decimal, I hope. What was it? 0.2 something? Okay, and then we're doing second sine, or inverse sine of that. And you can just leave the whole decimal in your calculator, it doesn't matter. When you type that, what did you get? 16.8 degrees, or
163.
Okay, looking at this triangle, can we throw either of those out?
These are 160.
Why can we throw the 163.2 away?
If you add it to 75.
Because if you add it to 75, it's bigger than 180, right? Doesn't work. All right, number 13 I have on its own screen here. Number 13 is given 3 sides. Okay? Side, side, side does determine a unique triangle. Can we use law of sines here? Yeah, we have to do the cosine one. If we are looking for this, which is not across from the longest side, so normally if you had to solve for everything, you would have started with the one up here, but we're going to start here. That's the only one they ask us to find. So you say the opposite side. So what's opposite of the angle we're finding? Squared equals, how's the rest of it go, guys?
6
10 squared minus 2 times those same 2 sides again. 6 times 10 times the cosine of the angle. Okay, how are we going to type that in? 7 squared, we're going to subtract the 6 squared and the 10 squared. Prediction, obtuse or acute angle? Yep, it's positive, so we should get an acute angle. Inverse cosine of 87 divided by 120. I am not in degree mode on my calculator, that's a problem. 43.5, anybody?
Yep.
Okay, do we have to worry about a second possible solution? Only law of sines, and only when you're looking for an angle. On the homework, I hate these. I tried not to assign too many of them. I'd rather give you 20 application problems to do than, I know, but then to give you 5 of these. Solve the triangle. Do you remember what that means? It means find all the missing sides and the missing angles, okay? So there are a few of those. After you did, if you had to solve this whole triangle, after you did this step, you could have said the sine of 43.5 is now across from 7, so the sine of B is across from 6, and so on. Okay? Yeah. All right, we're going to go on. Number 14. What are we doing here? Can we do law of sines? Nope, we got to do cosines. So this time the opposite side is the unknown. So it's going to be what? This one's just a typing question. 60 squared plus 70 squared minus. Times the cosine of 20. All of that multiplied together. And you get some big number that you have to remember to do what to? I think it's feet when we're done. Isn't that? I can't see, it's so tiny. I got 24.6. Anybody else there?
Yeah. So we won't have the programs on the content?
No, on the test, you will not have programs to use. Some of you have programs on your calculator that you type in the angles and the sides and it finds everything else for you. Okay? They're actually on all of my calculators, I think, right now.
Yeah.
Yeah. I am, when it comes that time. Okay. Pardon? Yes. Actually, there's a way you can lock them all down so you can't use any of the programs or apps. All right, area of a triangle, guys. What time are we out? 40? 35? Okay. I'm gonna cover a little bit of this. Area of, and then we'll come back to it tomorrow because I'd like 10 minutes to answer questions, but we're running short on time here. Area of a triangle, 1/2 base times height. That's from geometry, right? This is if you had honors algebra 2, you saw this one. When you know two sides and an included angle, you can find the area by 1/2 AB sine of C. And that's the one that I will give you on the formula sheet eventually. I will also give you this, which is given all three sides, okay? S stands for semi-perimeter. Anybody remember what this long thing is called? This formula is called Heron's formula, okay? This guy used law of cosines to figure out that if you have all the sides, you can find the area of the triangle. All right. Should have seen it in, yeah, college algebra. We do it in honors algebra 2. I don't know about honors geometry. Okay, real quick, this first one, what are we doing? 1/2 base times height equals 30 centimeters squared. This is two sides and an included angle, so we go 1/2 8 times 10 times the sine of 40. I got 25.7. Anybody else? We're finding areas, so those are square centimeters both. I'm going to skip number 17 for today. Whoops, going wrong way here, sorry. We're going to talk about this one tomorrow. I never use this big icky formula because I've never memorized it. I always just use law of sines to find this side over here and then use this, but we'll do that one tomorrow. I want to talk one time through Heron's formula. The semi-perimeter is halfway around. So if you add these up, you get 30, is that right? Divide it by 2, so the semi-perimeter is 15. The area of that triangle then is 15 times 15 minus 12 times 15 minus 10 times 15 minus 8. So it's 15 times 3 times 5 times 7 and square root of all that. $39.7, anybody? Okay. We could have used law of cosines to find one of the angles first, and then used my favorite, 1/2 AB sine C. All right, well, so we need to do 17 and 19 tomorrow, right? To finish up this stuff. What can I help with on the homework, though? I'm going to go ahead and let this record, I guess, for a couple of minutes. So Caitlin needs to look at the questions that you guys asked. Carrie?
Worksheet 4B, there's 9 through 12.
Okay. Worksheet 4B, come on, load up. Number what?
9 through 12.
Okay, number 9, you set tan x equal to 0 or tan x equal to -1. This is not worksheet 4? Oh, that's 4 side A, isn't it? You talking about B? Okay. Which number's on B?
Like 9.
At the top? Okay. This is 4B, sorry about that. Arc sine is defined as positive in quadrant 1. That's your colored unit circle. But on my colored unit circle, there's no 3/5, right? So I have to do opposite over hypotenuse. Okay. I do Pythagorean theorem, and this turns out to be 4. It wants the sine, though, Carrie. Do we already know the sine of that triangle? Okay. This one says, find the cosine at 7 pi over 6 on your unit circle. Can you tell me what the cosine is at 7 pi over 6? Square root of 3 over 2? Negative square root of 3 over 2. Okay, I made that. There we go. Now, on your colored unit circle, where can we look for a negative cosine? Yes, the colored unit circle says arc cosine is defined here and here only. So 7 pi over 6 doesn't work. Yep, down here at 5 pi over 6, we have this cosine value, so this evaluates to be 5 pi over 6. I think 11 and 12 are draw ones. Okay, yes.
The ones past 11 and 12 on the same worksheet, but there's one.
Okay, this first one is way easier than it looks, okay? There's a really easy way to make this work. What could you trade cosine squared for? That would, look what we're trying to get to, guys. Okay, so we have 1 minus sine quantity squared over a 1 minus sine squared. What does the top mean? 1 minus sine times 1 minus sine, right? What is the bottom? Ooh, sorry, that's a really crooked line. What does the bottom become? Can we factor that 1 minus sine squared? 1 minus sine times 1 plus sine? Then some things cancel, and we're left with 1 minus sine over 1 plus sine. Unfortunately, if you started off in a different direction on that, it just became very, very painful. Do you have enough on worksheet 5, Vincent, or you need me to do one?
Yes, one of them, 5B,
On 5B,
number 4.
is this 5B or 5A? I'm sorry. Is the 5B the sum and difference ones? Is that what it says at the top? Okay. And you want me to do number 5 maybe is the one you're thinking? Okay. Oh. But we don't have a trait on our sheet that says secant of 2 theta for anything, right? I think it'd have to be 1 over the cosine of 2 theta. I'm looking at the other one here to see it. Oh, yeah, let's try this one. Okay, so this is a 1 over cosine squared that is being divided by a 2 minus 1 over cosine squared, right? 1 over cosine squared is still being divided by, can we get a common denominator back here? This would have to be 2 cosine squared over a cosine squared, if I squeeze that in there. So I'd have 2 cosine squared minus 1 all over a cosine squared. I can't flip it over until I have one numerator and one denominator, one quantity. Now I can flip it over. These will divide out. So I have 1 over 2 cosine squared minus 1, which I assume is hopefully a trade for cosine of 2 theta. And 1 divided by the cosine of 2 theta would be the secant of 2 theta. That was icky. Did you get 4 now on that page?
Yeah.
Okay. That's why I didn't assign all of them, because they're just not nice. What about the other side? Nobody? I feel like we did a couple already. Did we? Okay. Anything worksheet 7? We didn't do anything off. What about the book? Did anybody do the book? I'm going to throw this up here. Can you look at this question really fast? Because I started to do this and it got really long and painful. Where do you see something that has a, this is number 8 off the book, sine cosine minus cosine sine? It's the sine of, is it a plus b?
It's minus.
It's minus, I think, yeah. Okay? It's a minus b. So for this problem, when I put in a is 2t, and b is 1t, rather than try to factor and trade and do a bunch of stuff, it just becomes the sine of t equals 0. Where's the sine 0? 0 pi and 2 pi, and I think if you look back, the directions said including both 0 and 2 pi. So this one does have 3 answers, okay? All right, have a great day, guys.